Is x plus 3 a factor of x to the fifth minus 2x to the fourth minus 6x cubed minus 3x squared plus 3x plus 279? Well, to determine this, the easiest thing to do is use synthetic division. So to determine if something is a factor, we look to see if the remainder is 0. So to get the remainder, we have to perform synthetic division of this polynomial by this linear in the denominator. So we start off setting the negative 3 off to the side. Because this is a factor and not a 0, we have to change the sign. Then we have x to the fifth minus 2x to the fourth minus 6x cubed minus 3x squared plus 3x and 279. Now, synthetic division, what I do here is I start off bringing the 1 down. 1 times negative 3 is negative 3. These add up to negative 5. Negative 5 times negative 3 is 15. These add up to 9. 9 times negative 3 is negative 27. Those add up to negative 30. Negative 30 times negative 3 is 90. 90 plus 3 is 93. And negative 3 times 93 would be negative 279. So these add up to 0. And since my remainder is 0, it is a factor. Is 2x minus 7 a factor of 16x to the fourth minus 72x cubed plus 8x squared minus 10x plus 623? All right, so here's a tricky thing. The denominator is linear, but the leading term coefficient here is not 1. We can still use synthetic division, but what we have to do is a little bit of prep work. So let me go down a little bit further and do that prep work. So essentially, what I want to do is take 16x to the fourth minus 72x cubed plus 8x squared minus 10x plus 623, and divide that by 2x minus 7. Now, we would like to use synthetic division as opposed to polynomial division. In order to do that, what I'm going to have to do is multiply top and bottom by a half. So that just changes the form of the divisor, but it doesn't actually change the value of anything, because essentially I'm multiplying by 1. So in the numerator, 16 times a half would be 8. So I have 8x to the fourth. 72 times a half is 36. So 36x to the third. 8 times a half is a 4, then minus 5x, and then the best I can do here is say plus 623 over 2. In the denominator, 2 over 2 is 1, so that's just an x, minus 7 halves. All right, so now I can use synthetic division with the term 7 halves. Just like always, I take the opposite of this value, so 7 halves into the polynomial 8, negative 36, 4, negative 5, and 623 over 2. All right, we start off bringing the 8 down. 8 times 7 halves. Nice thing is 8 is even, so 8 divided by 2 is 4. 4 times 7 is 28. Now if I take 28 minus 36, that is negative 8. So again, negative 8 divided by 2 is this time negative 4 times 7 is negative 28. Adding these two values together, I get negative 24. Negative 24 divided by 2 is 12, and 7 times 12 is 84. That's going to be a negative. These will add up to negative 89, and these won't divide so evenly. I'm going to probably need a calculator, though, because I don't know particularly what 7 times 89 is. Oh, it's 623. That's great. So this would be negative 623 over 2, and those add up to 0. So this is my remainder, And since the remainder is equal to 0, that is a factor. So it is. All right, the next one, x minus 4, is it a factor of 6x cubed? Sorry, x to the fourth minus 6x cubed, and so forth? Let's find out. So we take the number 4, divide it into the coefficients here. 1, negative 6, 10, 3, and negative 788. Doing the synthetic division, bring the 1 down, times 4, add up, negative 8, that's 2, that's 8, 11. 11 times 4 is 44. And you know, it really doesn't matter what this adds to. I think it's going to be negative 744. But the thing is, because it adds to negative 744, that remainder is not equal to 0. That's all that matters here in answering this question. So it's not 0, so therefore this is not a factor.